Howdy, howdy, everyone, and welcome to the Framework HQ. My name is Hyelim Choi, and I'm the content creator here at Framework. And today I'm with
the CEO of Framework, Nirav Patel.
And we are going to be talking about our webcam. So, in case you don't know, we're coming out with a new webcam later this year, August, right?
Yeah, we are shipping it this August. That's right. We announced it already.
So, we wanted to take you a little bit behind the scenes about why we did it, why we made it, all the cool new features and the engineering stuff behind it. So that begs the question, Nirav, why do we do it?
So why did we do it? So every year when we build a new version of the Framework laptop, we always think through, how do we improve this product further? What are people complaining about? What do people want to see more of? What are the press reviewers saying? And we talked a bit about the display earlier. We shared a blog post a couple weeks ago, and that was one of the key parts of it. And one of the other key things we decided to improve this generation was the webcam. People are on Zoom calls, team meetings, Google Meet, and they want better cameras. We all want better cameras. And historically, webcams have really lagged behind in laptops. And so we really dug into why is that and what can we do to fix it.
So when we start building a brand new product, where do we start? How do we make it? Do we start on Alibaba?
Sure, we do not start on Alibaba or AliExpress. So what we do is we usually dig into the supply base. We go to the various parts of the integration stack and figure out what the new technologies are that are currently available and what's on the roadmap, and basically just start to match between what we think the desired target product experiences and the technologies that are available that really intercept the schedule of the system. Because ultimately for this new generation Framework laptop, we really wanted to build the entire schedule for the development around the CPU schedule. And so it was really looking at what technology can intercept that and then taking it from there. So for the webcam specifically, of course, that meant more than anything else looking at the image sensor roadmap. And this also goes back to the problems really with webcams generally in laptops. Most laptops are using pretty old image sensors that are also just very, very tiny. Basically, companies are optimizing more than anything for squeezing the top edge of the bezel to be as tiny as possible. So using these like very, very small optical format image sensors. And then the other part of this is that just for many years running, image sensor vendors and laptop vendors and module vendors just really haven't invested in trying to do better cameras for laptops. And so now, of course, with people using video conferencing much, much more heavily, we're just now at the start of getting back to image sensor vendors taking this space seriously. And so when we started researching which sensor to use to like really, really improve the webcam, one thing that we found is that Omnivision, who actually also made the image sensor for our original webcam, made a totally new, fully new technology version of an image sensor specifically designed to make the video conferencing experience in notebooks much better than it has been. So basically they took all of this new technology that's been advanced very, very rapidly for the smartphone space over the last decade and brought it into a form factor and a resolution that makes sense for notebooks.
Why do you think it took so long for laptops to get this new tech or get these image sensors when they've been in cell phones for so long?
Yeah, this is a really interesting one. It's kind of this cargo cult mentality of basically chasing what the laptop makers think people want. And so what laptop makers for like a decade running thought people wanted more than anything else was for that top edge bezel to basically disappear. And so you can see like the evolution of notebooks over the course of the last 10 or 15 years is that area just gets smaller and smaller and smaller each generation. And so, basically the industrial design is like, okay, that's what it looks like. Now camera team, go and figure out how to make an image sensor and a webcam fit within that space. Not the way it should be, which is let's think about how people are actually using their computers, what they actually want out of their computers, and then design the full system design and architecture around that. And so basically as that space got smaller and smaller and smaller, that camera team had to go and find smaller and smaller image sensors to just fit in that. And it's kind of crazy, but you could see like really across that period of time, a bunch of companies trying random other things to make it even smaller, like removing the camera from the top edge of the bezel and having like nose cameras basically where like the camera is like at the bottom. There's some
like the pop-up one?
Yes, there's one where the camera is like inside one of the keys in the keyboard, so you like press the key on the keyboard and the camera is under that, because like that's definitely what you want to see when you're video conferencing with someone.
Very cute.
Yeah, so this was like just this wild phase where like notebook makers just did not care in the slightest about image quality for video conferencing. And so obviously we looked at that right from the start of Framework when we built the first version of the Framework laptop and knew that like, no, that's crazy. People want cameras that are better. And so our first generation camera actually is quite solid. Like the image sensor we used was one of Omnivision's older image sensors, but it is like from an optical perspective, a larger optical format than most laptop web cameras have. And also it is a 1080p sensor with like pretty good light sensitivity, but it still is based on that older process technology. And so we really did want to see what we could do with a totally new image sensor.
So what are the specs of our new webcam?
Yeah, so this is an exciting one. I've got a module here in our actual retail packaging, so I can take it out and kind of point out some of the parts of it. So the really key thing, the most important thing, of course, is this new image sensor. So it's called the OV08X. It's that new image sensor from Omnivision. It is actually a 9.2 megapixel image sensor, but importantly, we're not actually trying to use it at 9.2 megapixels. That is really not something that would be well supported in video conferencing software, which mostly runs at either 720p or 1080p. And so we really made sure to actually use the image sensor in a mode that makes sense. And so the cool thing about this image sensor is that even though natively it is 9.2 megapixel, it actually uses this binned mode, which is really actually quite common now in smartphone cameras. Part of the reason that smartphone cameras continue to go higher in resolution while still maintaining really great image quality is that they have this mode that's called binning, where basically groups of 4 subpixels can be combined together into these much larger, more light-sensitive pixels. And so this 9.2 megapixel camera, we're actually running it in a 1080p mode where those groups of 4 pixels are bucketed together, which means actually that we've got really great light sensitivity, we've got super low noise, and this plays out especially well when you enter darker environments.
So just to make sure that I understand what binning is correctly,
yeah,
it's like if you took a 4K video and shrunk it down into a 1080p timeline, so each of the pixels the 4 pixels occupy the space of 1 pixel.
Yeah, exactly. And we can actually whiteboard it to make it easier to understand. Okay, so part of what makes this image sensor really great is that it does use this new smartphone-derived technology called pixel binning. And so traditionally for a image sensor, you would see a pattern like this. So it's something called a Bayer pattern, or Bayer mosaic. And there actually are twice as many greens as there are reds and blues. But normally you'd see basically a structure like this. And so this grouping sort of gets demosaiced into pixels, these subpixels. So this would actually, even though it's 4 subpixels that are in different colors, this would get demosaiced into 4 pixels that are RGB pixels. And so the cool thing that this new 9.2 megapixel sensor does that a lot of these high resolution sensors and cameras do is that there's actually 4 pixels here. And so it's natively 9.2 megapixels when you split this out into these quad groupings of subpixels. But in the mode that we're actually using it in, it's a 1080p mode where we do actually bucket those 4 pixels into one higher sensitivity pixel. And so basically we end up with these super light sensitive, big bucket light pixels that run at a resolution that's actually useful because it's the native resolution that a lot of these applications want anyway. And so it ends up being just very much use case driven. So instead of having a 9.2 megapixel sensor that's actually not particularly aligned well to use cases, we have a great light sensitive 1080p sensor that gets aligned pretty well to the way you'd actually use the thing. So that's one of the 2 cool things about this image sensor.
Quick question for you, Nirav.
Yeah.
how do we access this configuration? Is it a hardware or is it a software thing that we code?
Yeah, so this is actually a configuration of the image sensor itself. So there's a camera controller that is in that camera module, this little USB. It's under this little piece of Mylar, or no, it's under the sticker actually on this side. The USB camera controller. So this camera controller has some firmware that then configures the image sensor to run in this mode.
Cool.
So that's one of the two cool things about this. The other cool thing, going back to image sensors and laptops typically being quite old, is that our original image sensor, and actually most webcam image sensors, use what's called front side illumination, which is kind of an older image sensor technology where basically it's going to be hard to draw. But this is like the pixel stack that I'm about to draw here. So this is like a micro lens on top that collects in light. And we're just going to go down through the stack. And underneath that, in the front side illuminated architecture, you'd get basically the internal wiring of the image sensor. So like everything that's connecting all the signals. And then below that, you'd get the actual light sensing pixel itself. And so it was built this way basically just due to the process technology that was available historically for image sensors. And so you can see the obvious problem here is that your pixel is here, the thing that's actually collecting the light. The light's coming in here, and between the two, there's all this circuitry. So you're not getting as great of light sensitivity because it's getting absorbed or bounced off by all, or bounced around by all this, effectively wiring in the middle. And so since then, there's been this new technology called backside illumination. And so, it sounds obvious, but actually there's just an immense amount of process technology that went into making this actually possible. And again, this is something that is now in most webcam or in most camera image sensors or webcam or camera smartphone image sensors. And so in this technology, in backside illumination, you still get that micro lens. Oh, actually, I forgot one thing here, which is the color filter. So basically the thing that actually enables these pixels to be these different colors is the color filter that basically selectively passes through light of the right color. So we'll just pretend this is a blue color filter for a blue pixel. And so in backside illumination, you still get that blue color filter there right underneath that micro lens. But then instead of having all that wiring there, the light sensing pixel is underneath the color filter, and then that wiring is underneath that. So basically you're not losing all that light or bouncing all that light off that wiring. It goes straight through the lens, through the color filter, into the pixel, the light sensing pixel element right there. So super cool. And actually technically what's in this OV08X from Omnivision, this brand new sensor, is their evolution beyond the traditional backside illuminated sensor from the front side illuminated. They have something that they call, their brand name is, it's called Pure Cell S. It's like some further advancement that they've done where in addition to it being backside illuminated, they've done some cool stuff where there's like some isolation or like greater isolation from subpixel to subpixel. And so I just drew a single pixel, but obviously there'd be a whole array of these things. And so Omnivision has done some cool stuff where there's basically just greater isolation between subpixels, so there's less potential for bleed or noise between the two. So super cool technology, all this great stuff, traditionally used or more recently used in smartphones, finally in a laptop webcam.
Thanks for teaching me about image sensors, Nirav.
Of course.
But what about the rest of the webcam module?
Yeah, sure. So of course the sensor is just one part of it. We've got a whole module here. So this module, we actually worked with Chicony, which is a big Taiwan-based module maker. They're actually the same company that we worked with for the 180 watt power adapter in Framework Laptop 16. So the same company does power adapters, they do webcams. They actually have like a skyscraper in Taiwan where every floor is like a different department. So you can kind of like shop the entire building and build an entire laptop, basically. But so far, we've just got the power adapter and the webcam from them. But obviously, this module has some other cool stuff. So, of course, pairing with that image sensor, we've got a new lens that goes with it. And this is a 2.0 f-stop lens, actually the same f-stop as our previous camera, but it is a 5-element lens this time instead of a 4-element. And it's a good high-quality lens. Beyond that, of course, we've got that Realtek camera controller. So it's a newer generation camera controller compared to the one we had in the previous version. Similarly, it interfaces over USB 2.0, but it's got some improved 3D noise reduction, temporal noise reduction, which is pretty cool. There's the ALS, the ambient light sensor. It's actually the same light sensor that we used on the previous version. It was working pretty well, so we felt that it wasn't important to change that. And then the microphones are actually improved. So we've gone over to 67 dB SNR microphones from 65 that we had before. Obviously, these are just numbers, but we'll kind of do a recording later so you can hear the difference.
Does this mean that they're more sensitive?
They have better signal to noise. So basically, for the same level of signal sensitivity, there's less noise that you'll hear, and they do have slightly higher sensitivity as well, which is great.
And then one other quick question. What is the difference between a four element lens and a 5-element lens?
Yeah, this is a tricky one. It's really just like basically the number of, it's the number of physical lens elements, the number of they're made of plastic in this case, so basically the number of physical elements there. But really the key behind the number of elements that are there is that it gives that lens designer, that optical engineer, basically more parameters to play with to optimize that lens to achieve a specific
so
result.
literally 4 pieces of plastic for light to push through.
That's right. And this is tiny, but incredibly enough, there are actually, so within that tiny little stack, there's the PCB, there's the image sensor that's wire bonded to the board, there's an IR filter, a blue glass IR filter, and then there's 5 plastic lens elements that are all stacked up.
All one angstrom thick.
It's just tiny little thing, yeah. And this one other thing that's great about having that 5-element lens is that with all those degrees of freedom, we were able to get an 87-degree field of view, so a little bit wider actually than our already pretty wide previous generation.
Nice.
And there's one other thing that's pretty cool, which is that we've improved the privacy switch behavior a bit further. So just like the first generation, we've got physical, electrical privacy switches for both the camera and the microphones. So when you flip that switch, it actually electrically cuts off the microphones or electrically cuts off the camera. And we've done some things to actually improve standby power consumption. So it's already obviously quite low, but we've done some things to bring it down even further from the types of sensors we use for the privacy switches. And then one other cool thing that we've done is that in the previous webcam, when you flip the camera privacy switch, it would cut off and power off the entire camera controller and also the image sensor. And so when you flip the switch, you'd see the camera actually disconnect off of USB. And then when you flip it back, it would reconnect over USB, which works. From a privacy perspective, that's fine. It works just great. But from a usability perspective, it means that it would take longer to basically, re-enumerate that camera and then, enter the video conferencing, whatever application you're using. There are also some video conferencing applications that wouldn't automatically detect that a camera had appeared, and you might have to restart the application. And so what we did this time instead is that privacy switch only electrically cuts off power to the image sensor and not the camera controller.
Ooh, that's clever.
Yeah, so it's different. So when you flip that switch, the image sensor is electrically powered off. So physically, we've got perfect privacy there. But the cool thing is that with that same signal, we let the camera controller, that USB controller, know that the image sensor disappeared, and we can show a fake frame. And so now we actually, when you flip the switch, instead of the camera disappearing, the camera switches to this baked in image that shows a little icon letting you know your camera switch is flipped. Okay, so we are in Windows camera application, and you can see this is just a new webcam. And the cool thing is when we switch that privacy switch, you get that little message. So Windows actually knows that signal passes all the way through into the operating system. And so it says your camera might be covered. And we showed this little icon just reminding you, hey, your camera privacy switch is probably flipped. And then we can flip it right back on, and it disappears and you're right back in.
All the technology is super interesting and cool, but this is what it actually looks like.
So this is the video and audio quality coming straight out of the new framework webcam module. And for some context, it's about 1700 lux right now lighting up my face. And so this is what the webcam looks like. So we're at around 5 to 6 lux right now. I'm in the storage closet in the Framework office, and the only light that's really lighting my face is the laptop display. I am really impressed with the low light performance. The only thing lighting my face right now is actually the display of the Framework Laptop 13, and I still feel like it looks really great. There's still some noise and grain in the background, which is of course par for the course of any camera. However, there is this really crisp line between where my t-shirt ends and where the background begins, and I think that's really a testament to the sensor quality. And this is the original webcam under dark light conditions. So you can see my shirt here is significantly grainier, and the clarity between the shirt and the background isn't as sharp as it is in the new webcam. And hopefully it sounds a little bit different too.
So this webcam module is compatible with both the Framework Laptop 13 and the Framework Laptop 16, and you can sign up for the waitlist in the link down in the description box. And the team is super duper excited to hear what you all think, and we cannot wait for you to try the new webcam module out. Any last words, Nirav?
Nope.
Awesome. Well, we'll catch you guys next time.